Hello, wonderful students. Today we are going to look at Mathematics Paper 2 Calculus in the ECZ Paper 2. There are two types of questions that come. We've got the definite integrals and the application of integration, where we are asked, for example, to find the equation of the normal, the equation of the tangent, the points, and so forth and so forth. Today we are going to look at the type 1 type of question where they ask to evaluate the definite integral. All right, so I have a few examples to help us. All right, so the first one is say evaluate. Question 1, we are evaluating this -1, 2. Then here we have 2 plus x minus x squared dx. When you hear this, anytime you are integrating, let's say if you have this integration of ax to the power n dx, the answer is just equal to, you need to increase the power by 1, n plus 1, then you divide by n plus 1 by the same new power. Since these are definite integrals, we don't add a constant of integration, so we just end it there. We're together, right? So same concept applies to this one. We are first going to integrate anything here. And take note that the integral of a constant, any number without a variable, all right, for example, 4 dx, the answer is just 4x. And let me explain why the answer is just 4x. Here's the thing. If I write 4, are you going to agree with me that it's the same thing as 4x to the power 0? Yes, you should be able to agree, because x to the power 0 is 1, and 1 times 4, you are still getting 4. So if I decide to increase 1, I divide by 0, 1, I'm getting 4x to the power 1 over 1, which will just give me what? 4x. This is why I said the integration of any constant is just the same number, then add the variable that you are dealing with. All right? Then, this is what we call the fundamental theory of calculus. So if you've got a, b, let's say f of x, the answer is fa fb minus fa. What is f? You can see here that I'm using a small letter, and here I'm using a capital letter. This is already an integrated function. Then you replace b. So we are going to do the same here. So integrating 2, I'll get 2x. Integrating x, I'll get x squared over 2 minus. Integrating x squared, I'll get x to the power 3 over 3. Then I'm going to introduce my limits, -1 to 2. The one on top is called the upper limit, and the one at the bottom is called the lower limit. So we are going to establish this relationship there. So FB in this case is when we substitute 2 there. FA is when we substitute -1 there. So can we do that? All right, so let's first find let's find F2. All right, so by substituting 2 there, I put 2 there, squared. I put 2 there, over 3. What do I get? So that becomes 4. This is 4 over 2, get 2. This is 8 over 3 minus 8 over 3. This will give me 4 and 2 get 6. 6 minus 8 over 3. When you evaluate this, you end up having, by the way, this is paper 2, so feel free to use a calculator. So minus 8. So this is giving me 10 over 3. So exactly, so this will be 18 minus 8, which will give 10 over 3. So you leave it like that. Next, you go and find f of -1. So where there is that, we put -1 plus -1 squared over 2 minus -1 to the power 3 over 3. We move on. This will give us -2. This is 1. This will get 1 over 2. Here we get negative, but there's also another negative there to give us -1 over 3. And here again, you can see that if I multiply these two, then I add 1, what am I getting? I'm getting -4 plus 1, which gives me -3 over 2 minus 1 over 3. I'm getting something like this. Yeah, -4 Yeah, correct. I can now evaluate this one because I know that the number which can go into where 2 and 3 can go is only 6 there, right? And 6, 2 into 6 is 3, multiplied by 3, negative 9, minus 3 there is 2, so get negative 2. So the answer just comes to negative 11 over 6. Now we're not done. Remember, we need to subtract them. Therefore, f2 minus f negative 1 is just equal to 10 over 3 minus negative 11 over 6. What we get? We get 10 plus 11 here over 6 here over 3. We can continue. We find the common denominator 6. 3 into 6 is 2, so we get 20 there, plus we get 11 there. So we end up having 31 over 6. You can leave this as a mixed fraction if you want to give us 5 remainder 1 over 6. You do not add any units because you haven't been told which one you are finding, whether area or volume or anything. So you just leave it like that. So let's put up another one. Another one is integrating 0 to 1. Here we have x squared minus 2x plus 3 dx. Let's first integrate this. So if we integrate this, we end up having x to the power 3 over 3 minus 2x squared over 2 plus 3x. Our limits, of course, is from 0 to 1. We know that we can simplify this one further, and we can have the final answer to be, all right, which will give us x power 3 over 3 minus x squared plus 3x. We are going to maintain our limits. So let us now find f of 1. F of 1, we put 1 there, we get 1 over 3. We put 1 there, we just get 1. We put 1 there, we get 3. This will give us 1 over 3. We evaluate this part, we get plus 2. 3 times 2, 6 plus 1, 7 over 3. We keep it. We evaluate f of 0. If I put 0 here, 0 there, 0 there, I'm just getting 0. So therefore, f of 1 minus f of 0 is just equal to 7 over 3 minus 0 to give me 7 over 3. If I divide there, I'm getting 2 remainder 1 over 3. Now, let me give you what you are going to work out. Here's a question for you. Evaluate this. Okay. Negative 1, 3. 3x squared minus 2x dx.